Hello everyone, my name is Nand Kishore Yadav from ABES Engineering College Ghaziabad. Today I am going to discuss a linear queue data structure and its various operations. Firstly, let us see what are the basic operations we have to perform in linear queue. So when we add some element in linear queue, then we have to perform insertion operation. So insertion operation is just adding elements in linear. In deletion operation, we want to remove an element from linear queue, then the operation is called deletion operation. If we want to visit each element which we have inserted in that linear queue, then we have to perform traversing operation. Let's see each operation one by one. So firstly, let us see how to perform insertion operation in linear queue. So suppose we have taken an array queue of 5 elements. Okay. So here queue is an integer type array. So we can see that this array contains index 0, 1, 2, 3, and index 4. Suppose in starting at both ends, the value of front and rear is at -1. So let's assume here front is equal to -1 and rear is equal to -1. But in starting, the key is empty, then the both value is at -1. Suppose we want to insert element like 20, 10, 30, 11, and 6. These element we have to insert. So firstly, we have to insert 20 here. So before inserting 20, we have to set the value of front and rear. Now set value of front from -1 to 0 and value of rear from -1 to 0. So here it means front is set at this position and rear is also set at 0. Now we have to insert element 20 at 0th location, 0th index. So here, as per algorithm, we have to write 0 here and value 20 is inserted at 0th index. So this is 20 now. Now, if you want to insert 10, then we can insert this element 10 at rear end only. So we have increased the value of rear only. Front is remain at same position. So here we will just increment the value of rear from 0 to 1, and here we can insert array next value 10. Okay. This value 10 at 1 index. From here we can see that 20 now value 10 is inserted at index 1. Now next value is 30. Before inserting 30, we have to increment value of rear at index 2, and 30 is inserted at this one. Now if we want to insert 11, then we have to increment the value of rear from 2 to 3, and 11 is at this one. If you want to insert 90, then again increment value of rear from 3 to 4, and we can insert 90 here. Now suppose we want to insert 60, then there is no location vacant to insert 60. So this is called the overflow condition. Let's see how do we write the algorithm for insertion operation. In first step, we write insertion in queue, and we have to insert data. First step, we'll write if value of rear, so value of rear is equal to size minus 1. Size is 5 here, so we have write size minus 1. Then print 4 over nx. So if already queue is full, then we can't insert 90 here. So this condition is called overflow. So in the first step, we will write the overflow condition. In second step, we will see if queue is empty, then we have to set front and rear both heads. If a rear is equal to -1, then set front is equal to -1 and rear also is equal. In third step, we will write we just increment the value of rear. If rear is at 0, then we can move to 1. If rear is 1, then we can move to 2. So here at each time rear is just incremented by 1. Here we will just write rear is equal to rear. At last, we have to insert element at that location. We will write here q at a rear is equal to data we want to insert in that. And last step is act. So in this way, we can write an algorithm for insertion operation in a linear. Now let's see how do we perform deletion operation is that. So for that, we just again taken an array A that q, okay, for 5 element. So q is for 5 element. So in starting, if there is no element, this condition is called underflow condition. So in this deletion algorithm, we just write deletion of q. Okay. So in the first step, we write if there is no element, it means front and rear both are at -1. So here we'll write the front is equal to -1. Then this condition is called underflow condition. Then print underflow and exit. So this is underflow case. Now in next step, suppose there are some element like 10, 20, and 30. Front is at this one and rear is at this one. So for front is at this one and rear is at index 2. So in this case, what we do? We just store this element 10 for future use. So what we write here? Now data. Data we have to save or print here. So data is equal to q of front. Now, then after saving this data, we can increment the value of front here. So if we want to delete 10, so 10 will be incremented from 0 to 1. So here we can move from this. Okay. In this case, we will write here front is equal to front plus 1. Okay. Here, if the value of front is at 0, we can increment it to 1. If the value of front is 2, we can increment it 3. There is one more case pending. If both element both values, means front and rear are at same position, means we have deleted this one, then front is at here. Now we have deleted this one, the front is at this location. So here we can see the value of front and rear is both at index 2. So this is called a single element in that array. This condition is happen, then we can write here before moving front. So before moving front is equal to front plus 1, we can write here step 3. It will be if front is equal to rear, then front is equal to -1 and rear is also is equal to 1. Now in fourth step we can write here else front is equal to front. So we have to include this step also. Okay. Now if there is not a single element in the queue, then we just incremented the value of front from 0 to 1. If it is 1, then we'll increment it at 2, like that. Now in fifth step we can write exit. So this in this way we can write an algorithm for insertion operation in a. Now how do we perform traversing operation in that case? So suppose we are having array Q of 5 elements. Again, if there are elements like 20, 10, 30, index 0, 1, 2. So value of front is at 0 and value of rear at 2. So in this case, if we want to print the elements from 0 to index, that in that case we have to perform traversing operation. So let's see how do we write an algorithm for traversing operation in this case. So in first step we write traversing operation in Q, and we will also take here we have to also given the value of front and rear also in case of traversing operation. So here we can write front and rear both. We have to give in that case. So in the first step, we have to choose a counter variable or for iterations. So here I is equal to set at front. In second step, we can apply a loop. So we have to write here repeat steps while rear I less than is equal to rear. In third step, we just write print print q of we just write print q of the fourth step. We can increment the value of I here. I is equal to I, and this step we can perform exit. In this way, we can write the algorithm for traversing operation in the for linear queue. Thank you very much.